Hi folks, and welcome back to Math with Captain Rod here. I'm making this video here to be video number 2 here in our series of graphing rational functions. So here's another example here of a rational function. And you'll notice, it's very common here. I tend to do this in all my videos. Start very simple and make them get progressively a little more interesting. So first of all, let's talk about the asymptotic behavior here. Let's talk about vertical asymptotes first. So this function right here will go undefined anytime x squared minus 9 is equal to 0. Right? So if x squared minus 9 is equal to 0 and you solve that for x, you get x equals plus or minus 3. So these are values that this function is not defined for. So we would say, all right, the domain is all real numbers except x cannot equal plus or minus 3. And hopefully you've seen my other videos here. What typically happens here is you get vertical asymptotes. I'm going to go ahead and put these in. 1, 2, 3. All right, and one on the left. 1, 2, 3. All right, so our function is undefined at those values. Let's talk horizontal asymptotes. All right, so for horizontal asymptotes, oops, we don't like that. Right? We take a look at what happens when x gets really large. So if x is really large, our function here is approximately equal to 6x squared up top and just x squared in the bottom. Because x squared minus 9 is approximately just x squared for large values of x. And you'll notice these cancel. And we get 6 out of this. So what this means is when x gets large in both the right direction and the left direction, or in a positive or negative sense, the function is approaching 6. So y equals 6 is our horizontal asymptote. So 1, 2, 3, 4, 5, 6. All right, sketch this in. Okay. And I had done, oops. And we'll go ahead and use the a little bit thicker colors. Okay, so there we go. There's our asymptotes here. Whoops, that's not going to help us much. All right, so typically now what you do is now we'll try to get some function values here. And once you got the asymptotes down, a lot of times you do not need a ton of information here. Let's see how few points we can get this done with here. All right, x, y. Let's take a look at this. Negative, or let's see here, what are we at? Negative 1, 2, 3, 4, 5, 6. Well, let's try negative 6. I'm just trying to find a function, just something over in this region here. And give me a moment here to run a value. I get 8 out of that. All right, so negative 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8. There's our point. I'm just going to do this now. We know that it's got to approach the asymptote this way. Got to approach the vertical this way. All right. Let's try a region in here now, between minus 3 and 3. How about 0? That should be an easy one. You put 0 into this function, you get 0 up top and negative 9 in the bottom, so we get 0. So we know this thing goes through 0, 0. All right, now, what's happening kind of in this region here? Let's try negative, let's see, this is negative 2. Let's try negative, say, 2.5 and try to figure out, is it going down or up? So I'm going to run a function value here and see what we get. Oops. Give me a moment here. Okay, so I got negative 14 out of this, negative 13.6. Now, what that tells me is at 2.5, we're way down here. So that's telling me that this graph is definitely doing this. Right. Now, we can run this again at, we have to kind of see what's happening over here. But you'll know, when you look at this graph, this is an even function, right? See how the top is up second power, bottom second power. So if I run positive 2.5, because this function is even, I'm also going to get 13.6. You can try it for those of you who want to run 2.5 through this and see. Or I'm sorry, we'll get negative 13.6. So as we approach 3 from the left, this thing's got to be doing something like this. All right, let's try something over to the right now. So let's see, 1, 2, 3, 4, 5. Let's try 6 out of this. Now, we have an even function here again. I already ran negative 6 and got 8, so if I run positive 6, I should get 8, or I will, since it's even. Again, exercise for the reader, go ahead and run 6 through this function to see what you get. All right, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. There's my point. I know that it has to approach the asymptote this way. There, we'll just do that. And I know it's got to approach the horizontal asymptote as well. Ooh, that could have definitely turned out a little better. Okay. So there's just at least a rough sketch of that function. Good enough. Let's see, we're at 7 minutes. So go ahead and maybe take a look at another example. All right, so this animal. All right, let's talk about the vertical asymptotes here. If 16 minus x squared is equal to 0, the function will not be defined. It's pretty easy to solve this. X equals plus or minus 4, so our domain is all real numbers except x cannot equal plus or minus, or minus 4. So vertical asymptotes at x equals plus or minus 4, 2 of them. All right, horizontal asymptotes. It's really easy to show. If x is really large, this function is going to 0. If you want to convince yourself, put 100 into it and see what you get. You're going to get like 0.000 something. Put 1,000 into it, or 1,000,000 into it, and you're going to get 0.0000000 something. When x gets really large, this thing's going to 0. Anytime the bottom is a higher power than the top, the function, or y equals 0, will be a horizontal asymptote. So we'll draw those in. 1, 2, 3, 4. Negative 1, 2, 3, 4. Okay, we're good. Been using green here. Let's stick with that. For the horizontal asymptotes, almost can't see it there. There we go. All right, so now that we got the asymptotes in, now we can start plotting our function here. So again, you typically just need a few data points here once you have those asymptotes. So we might try, let's see, maybe -5, and let's see what we get out of that. So let's see, what we're going to get here is, okay, minus 0.11. So negative 1, 2, 3, 4, 5, negative 0.1. All right, so this thing approaches these this one's approaching these asymptotes really quickly. Just a moment here to think about that for a second. Yep, so this thing's got to be doing this. It's got to approach the asymptote. Oh boy, that could have been. That definitely could have been better. Let me see if I can resketch that. Boom, approaching the asymptote. There we go. Good enough. I know that it does not cross the axis here. One of the ways I know is, like, if you put 0 in for y, there's no solution to this thing, so it does not cross the axis here. We don't have to worry about that. This thing, I hate when it changes. All right, let's take a look at what's happening in here. Let's try x equals 0. Y is going to be 1 over 16. That's going to be a very small number. I'll just put it barely over the axis here. All right, so let's see. My guess here is things no doubt going to be doing something like this. I may test one value just to see. Maybe we'll put what are we going to put in there? Let's put 3.5 in, just to kind of say, all right, what's happening when we're getting close to the asymptote there. So our function here is going to be 1 over 16 minus 3.5 squared. I get 0.27. That's curious. I'll plot just a couple more here. Let me try 3 here. .142. Okay. And then let's approach this a little higher here. So let's try, and I guess we'll try 3.9 or something. .3 or 1.27. All right, so 3.9 is pretty close, and 1.27. Boy, this thing's really, really staying shallow here. I'm a little surprised. I wonder how that is happening. Undefined at 4. Just going to check these values again. 1 over 16 minus 3.9 squared. Okay. How about 1 over... Oh, you get out of there. Yeah, so what's happening is this function is really stays close before it takes off here, basically. And it's an even function. So it's doing kind of the same thing over here. Yeah, it's a strange one. I'm really surprised at how close we had to get before the function starts getting bigger and bigger. If I'm going to run one more here, 3.99, just to kind of show what that does. So that's 1 divided by 16 minus 3.99 squared. Yeah, 12.5 out of that. There it goes. Finally, we had to get really close before the function started getting really large, but okay, that's what it does. Stays pretty darn flat. Have to get really close before it goes vertical. All right, let's take a look at what's happening over here. Now, this is an even function. We should end up with exactly the same thing, but 1, 2, 3, 4, 5. Yeah, let's run 5 through this function. Oops. All right, we're getting negative. Oops, ran out of room. X, Y, I put 5 in, and I got negative 0.11 in. Now you'll notice that when I put minus 5 in, we got negative 0.11. Again, this is an even function, right? So changing the sign on the input gives you the same output. So 5, negative 0.11. It has to, it's approaching the asymptote over here, going straight down. Approach the asymptote, heading to y equals 0. And there's our sketch. So here's a real rough sketch of this function. He plotted more points than I thought I would need to get a decent graph, but you can check that, take any graphing utility and check it, plot it maybe from, he might do from like minus 20 to plus 20 in both directions here, and check that graph against this. So anyway, this video is getting plenty long. I think I'll just end that right here. Have a great day.